starting at the beginning here with the square root of 81, there's actually two different ways that I would recommend doing this. What's one of the ways we could do it? Okay, we could do a factor tree. So if we do a factor tree, we could get 9 times 9, and then the 9 is 3 times 3. And so we can rewrite the square root of 81 as the square root of... Okay, then what? Then we circle pairs, so we have a pair of 3's here, and we have a pair of 3's here. Since everything's circled, everything's going to end up on the outside, which means the square root is going to be gone. So what we end up with on the outside is 3 times 3, which is 9. And again, there's no square root because everything was circled. So we get 9. One of the biggest mistakes that we see is we take a square root, everything ends up on the outside, but you put a square root on it anyway. And if you do that, then you end up getting 3 because the square root of 9 is 3. But that's not the right answer, so be careful about that. Now, there is a quicker way to do this one in particular, because 81 is a perfect square. So instead of factoring it and circling the pairs, we could rewrite it as 9 squared. And then when we do that, what's going to happen with the square and the square root? They cancel each other out. So the square and the square root go away. Again, the square root is canceled, so that's gone. The square is gone, and that just leaves the 9 all by itself. So when the number we're trying to take the square root of is a perfect square, you can do it this way and save yourself a little work. Okay? It doesn't matter which way you do it, as long as you show all your work correctly, you're going to get full credit for it. Moving on to the second one then. Square root of 60. Is that a perfect square? No. So this one, since it's not a perfect square, we've got to do it the long way. So we're going to factor it. 60 is 6 times 10, and then 6 is 2 times 3, 10 is 2 times 5. So we can rewrite the square root of 60. Remember, when we rewrite it, we should put an equal sign in between. And under the square root, we should have what? Okay, and then just like the last one, we circle pairs. This time, not everything's circled, so we're going to have stuff inside and outside. So what do we end up with on the outside? And the inside? Moving on to this one. This one we have 2 square roots, but they're separated by a plus. So before we do anything else, can we combine these? No. We cannot combine them into one square root unless they're like terms. And right now they're not like terms because we have different numbers inside the square root. Okay, one other thing I want to say is when you're taking the test, or when you're working on the review sheet, or when you're working on your opener, you are allowed to use your notes. So for this one, if I'm looking for notes to help me out, I'd probably be looking for notes that says adding square roots, since it has a plus here between the square roots. You find those notes, it'll have not only the steps on what to do, but some example problems on there that might help you out. All right, so what is the first step to simplifying something like this? Factor trees. All right, so 20 is 4 times 5, and then 4 is 2 times 2. And then we'll also factor the 32. We could do 4 times 8. Okay, now what? We're going to rewrite it. Again, when we rewrite it, we want to put that equal sign. And some people get this mixed up with multiplying because we've also done multiplying now. When we multiply, we can put them all together in one square root, but we need to make sure we don't do that here because they're separated with that plus. We have 2 separate terms. We can only combine those if they're like terms. So we're going to rewrite each one on its own. So instead of the square root of 20, we have square root of 2 times 5. And then instead of the square root of 32, we've got 5 of them, right? Okay, then we'll circle pairs just like we did in the last problems. So we've got some pairs here. So we end up with, What do we get on the outside of the first one? 2 square root of 5. And then the second one? 4 square root of 2. All right, can we combine these?
No.
No, we can't because they're not like terms, right? So are we done?
No.
No. So this is another common mistake that we'll see on this. You want to make sure that you write them in what order?
Least to greatest.
Least to greatest. If you're looking at the radicands, we want to write them in order from least to greatest. So the smaller radicand is the 2, so that term should go first. So we do need to rewrite this. We'll have 4 square root of 2 first, and then 2 square root of 5 second. Separated by that plus because we're still adding them together. All right, same thing on this one, right? So if we're adding square roots or subtracting square roots, it's the same steps. It's just we're going to subtract instead of adding. 162 is kind of a big number. I don't see that number on a multiplication chart usually, but I know it's even, and since it's even, what do we know? It's divisible by 2. So let's start with that and see what happens. How do I figure out what I multiply by 2 to get 162? Yeah, 162 divided by 2, right? Punch that in your calculator, you get 81. 81, we know how to factor that. That's 9 times 9, and then each of those 9s is 3 times 3. All right, and then the 50, that one's not so bad. We get 5 times 10, 5's prime, and then 2 times 5. So we rewrite, just like we did in the last problem. When we rewrite it, we're going to put an equal sign at the beginning of the line, and then we're going to have everything in a row here. So for the square root of 162, now we're going to have square root of 2
times 3 times 3 times 3 times 3.
Okay, and then for the 50,
2 times 5. 2 times 5 times 5.
okay, then what?
Circle pairs.
Circle pairs, so we got a pair of 3s, and a pair of 5s, and those pairs are going to go on the outside. So the first one is?
9 square root of 2.
And the second one?
5 square root of 2.
Okay, and also don't forget to bring down that minus sign from step to step also. Are these like terms?
Yes.
Yes, so we can combine them, right? What is 9 square root of 2 minus 5 square root of 2?
4 square root of 2.
Good, so we just subtract the coefficients, leave the radicand the same. On this next problem here, we want to multiply them. This is the bottom one on your sheet. We want to multiply these together. So if I'm looking for notes to help me out on this one, I'm going to look for something that says multiplying square roots. All right, if I'm going to multiply these together, what's the first thing I'm going to do? Yeah, we're going to do a factor tree. Now the first step in your notes actually says to multiply the coefficients, but we're also going to need to do the factor tree, and that takes a little space, so we'll do that first to make sure we have enough room for it. So we're going to factor both of them. And then once we've factored them, what do we do next? Yeah, we're going to multiply the coefficients. We're going to actually do what the first step says in our notes. So we're going to do 2 times 7 and get 14. And then what do we do with the radicands?
Square root.
Yeah, we're going to put them in the square root, and we're going to put them all together in 1. All right, keep in mind when we're multiplying here that this is all one big term, so we can combine them all into one big square root. So we're going to combine all the factors from the 50 and the 30 in one square root, and we want to put them in order so that we end up with pairs next to each other. All right, so we have, I see 2 2s,
3
and 1 3,
and 3 5s.
3 5s, okay. Now what we're doing here is actually the same thing as multiplying 30 times 50. But what we're doing is we're multiplying the factors of 30 times the factors of 50 so that when we have it factored, we can do what now? Circle pairs, right? So we're just trying to simplify this square root. So the reason we factor it and combine all the factors rather than multiplying 30 times 50 is now we can just circle pairs and we're almost done. When we circle those pairs, we have a pair of 2s and a pair of 5s. So what's going to happen with the 2 and the 5?
They multiply by 10.
They go on the outside. Yes. So 2 times 5 is 10, and then we'll multiply it by the 14 that's already there. 14 times 10 is 140. Or you could just punch in your calculator, 14 times 2 times 5. It'll give you the same thing, right? And then what's left on the inside?
15.
So we get 140 times the square root of 15. All right, this one, since we have a fraction, what operation are we doing? Are we adding, subtracting, multiplying, or dividing?
Dividing.
We're dividing, right? So if I'm looking for notes to help me out here, I'm going to look for dividing square roots notes. All right. What's that?
They're not like terms.
Well, they don't have to be like terms here. So what we're going to do, going through those steps that we talked about last week, first thing we want to do is we want to simplify coefficients if we can. Okay, but we only have a coefficient of 6 on top, right? And that's the only coefficient. So we can't do that. We want to simplify radicands if we can. Here we only have a square root of 3 on the bottom. That can't reduce with the 6 because the 6 is on the outside, the 3 is on the inside. Also with the square root of 3 here, we cannot simplify that by itself because there's no pairs, right? We can't factor it and pull out pairs. So there's no simplifying that we can do, but we do need to get rid of the square root in the denominator. All right, so remember that rule. We're not allowed to have square roots in the denominator, so we're going to try to get rid of that. And that's the step where we multiply by a square root over a square root. And what do we put in the square root here? 3. It's the square root that we're trying to get rid of, right? So whatever the square root is in the bottom, that's what goes in the square root. So we're going to multiply by the square root of 3 over the square root of 3. Now, the top one, when we multiply 6 times the square root of 3, can I multiply the 6 and the 3 together to get 18? Why not?
One's on the inside, one's on the outside.
One's on the inside, one's on the outside. So what we're going to do is we're just going to keep the 6 on the outside, keep the 3 on the inside. We get 6 square root of 3. On the bottom, though, we can multiply those together because they're both square roots, right? Now, normally when we multiply square roots, we're going to multiply the insides together, and we would get 9, so we'd have the square root of 9. But this is a special case where if we multiply a square root times the same square root, what do we get?
The number without the square root.
The number without the square root. So in this case, it would be 3. And we're done, right? No. What do we need to do? Gotta simplify. Okay, can we reduce this 3 with this 3? No. Can we reduce the 6 with the 3? Yes. All right, so if we reduce that, what goes into both of those? 3, right? Actually, we can just do 6 divided by 3, can't we? So if it divides evenly, what we can do is just divide that, and we get 2 on top and nothing left on the bottom. Okay, what's really on the bottom, though? A 1, but do we need to put the 1? No. So what we end up with is 2 square root of 3. All right, last one. This is also a dividing square roots problem because it's a fraction, right? So, can we reduce coefficients? Can we reduce this 3 with anything?
No.
Can I reduce the radicands?
Yes.
Yes. The 5 and the 10 can reduce. What goes into 5 that also goes into 10? 5. So if we divide by 5, what do we get on top? We get 1, but do we need that 1? No. Anytime we get a 1, we can get rid of it unless it's the only thing left on top of the fraction. If it's the only thing left on top of the fraction, we got to have something there. So we put the 1 there. What about the bottom? 10 divided by 5 is 2. So if we rewrite this, what do we have on top still? 3 on the outside, right? And what's on the bottom? 2. Square root of 2, right? So when we canceled this 10 with the 5, those are both inside numbers, so we need to make sure we get an inside number, a radicand, when we do that. So we get 3 over the square root of 2. All right, so we've simplified, but we still have a square root in the bottom. So what do we need to do? Multiply by square root of 2 over square root of 2. And what do we get on top?
3 square root of 2.
And what do we get on the bottom?
2.
Okay? Now what?
That's it.
That's it. The 2's can't simplify because the one on top's on the inside, the one on the bottom's on the outside. The 3 and the 2 cannot simplify even though they're both coefficients because there's nothing that goes into both of them. So that is your final answer. Put a box around it.